great talk from Volker. I think that's a good primer on the various ways that you can configure or orchestrate on top of Sonic the various interfaces and processes. A few things about me. My name is Chris Lavery. I'm from Weaveworks. We're a strategic partner with Deutsche Telekom working on Das Schiff. And I'm not from Germany, as you can tell. I'm from Ireland, so I'm happy to be here at OCP. Thanks for having me. So the agenda for this talk starts with an overview of the principles we're using in Das Schiff for the platform and the paradigm shift we're making towards configuration as code, which is complemented by the term infrastructure as software. And hopefully we'll have some time at the end to look at a demo and discuss. So if you weren't here earlier for the previous talk on the Deutsche Telekom Kubernetes platform, here's a reminder. Das Schiff is a Gitops-based Kubernetes cluster as a service platform almost exclusively built using open source components. It's created by and intended for production use at Deutsche Telekom Technik to provide Kubernetes clusters to internal teams. It is hosted on-prem in both vSphere and bare metal at various private data centers in Germany. We currently support various containerized network functions for everything from 5G core to more typical fixed line services, and we want to continue in the spirit of cloud native and run a cloud which can scale and serve thousands of customers and possible use cases. So we carry the principles of cloud native software in our thinking and try to adhere to these in our design. So these include things like being 100% upstream compatible with Kubernetes with no additional complications, that our clusters can operate 100% standalone. They're 100% infrastructure agnostic. They're 100% declaratively driven, which means we don't need to think about the how, and we can just focus on the what. They're 100% immutable down to the OS, and they're 100% GitOps managed and automated, and that term GitOps will come up again and again, and I look forward to questions on it. So with those out of the way, we began an architectural review for what we needed to orchestrate our bare metal networking environment. And these guiding criteria were based on shared experience between the DT networking team. So shout out to Jens, who's here in the audience, and other team members like Marcel Fest, Christopher Giamba, and Max Rink, who all had input and contribution. The three key points that I'd like to take away from, or I'd like to profess a strong desire to reach, are that we wanted dryness, as in don't repeat yourself, so that we minimize repetition, complexity for edge use cases where necessary, and simplicity where it's viable. And we wanted flexibility because we may need to diversify beyond any single vendor and introducing the right hardware for the right use case as needed. Actually four. And safety. Running our config builds in a pipeline which links and validates each discrete file type and ensures that we're minimizing the risk that we introduce when we're enacting change in our environment. So a few benefits that we get from a configuration as code approach. We can independently reproduce our configurations through a consistent and shared approach in a pipeline. We can extend the same pipeline to test for defects or violations against our organizational standards. We can collaborate with code review in pull requests and reason about change through generated diffs. And we can control the speed of our delivery at scale, ensuring that our platform team is minimizing friction without compromising quality. So we have a pipeline built. We have a pipeline from the humans on the left to the devices on the right. The pipeline checks and runs validators and linters on each config.db.json file we generate, and it ensures they conform to our standards. If everything looks good, we build a tarball and upload that tarball to a virtual repository hosted in Artifactory. And when a switch boots from ZTP, that's how it obtains its base configuration. So ZTP and ONIE install and upgrade process are pretty useful and complementary to how we want to drive infrastructure. Devices get their source information from a repository, which holds artifacts derived from CI/CD. And the ONIE or ZTP installer are a way of thinking like just to use the term batteries included, let's say. They're a way of reusing an agent approach that is helpful in a configuration management context. So we know how configs are created and how they are managed as artifacts of a pipeline and how day zero provisioning is handled. But what about the lifecycle management beyond that? We can reuse a similar delivery and deployment model. We can't use ZTP as we need to manage the state and change without interruption, as Jens pointed out earlier. So we take that approach by generating OCI in the same pipeline. And what OCI are Open Container Initiative standardized images. So our configurations for change beyond day zero are actually discrete Kubernetes manifests that are consumed by an operator. That operator has a one-to-one relationship with each custom resource and a controller that reconciles those manifests. So we use operator SDK, and that allows us to continue on the path that we were originally on when we started looking at configuration management with Ansible and we were comfortable with. But it also uses Kubernetes as a reconciler, so we get the operator pattern, and that is in the Kubernetes world an incredibly valuable, how do you describe it, a pattern that is synonymous with an eventually consistent distributed system. The Sonic operator is one half of our delivery process. The other half is Weaveworks Flux. And Flux is what's really taking these OCI artifacts, consuming them, and passing the manifests through into a Kubernetes cluster where the operator resides. So it's able to detect drift. It's able to verify the reference to each image. It's able to even to be extended by policy, so that we ensure that we have full control over what we are consuming in our orchestration plane. With regards to the custom resources for Sonic, we have three main types. I have an inventory config, a platform config, and a port config. So an inventory config just deals with much in the same way as any asset management system, a listing of a given device. Platform config will handle the day one activities that we couldn't handle in ZTP. And the port config or switch port config is a custom resource that we created for handling that SRIOV use case, so that you're able to, in the first instance, ascertain that you have the correct piece of inventory that you're acting on, that you're able to manage its life cycle through the platform config, and that you're able to extend the self-service aspect of our platform to our tenants by giving them or their owners the capability to use Gitops to run their own SRIOV or interface configuration as needed. So you can see the whole pipeline here together, and I realize I'm getting close to time, and I really wanted to show people the demo, and I knew it would be really tight. So I appreciate this is a lot to take in, and this is a lot of documentation or slide-based presentation, so it'd be nice to show you what this actually looks like in a running system, which hopefully I can switch to. But to re-summarize from left to right, our team create a PR, we push to GitLab CI, we merge in the main, a CI job builds our artifacts and configuration. Our configurations go into output, where a config.db.json file is then pushed to the virtual repository. OCI artifacts are simultaneously created for the day one config, which are pushed across or pulled through by Flux, but pushed across into a Docker registry in the same Artifactory instance. And the switches are then able to, the operator is able to reconcile any differences that ZTP has not consumed, because if ZTP isn't running on the switch when you make a change to configuration, nothing's changing. But the operator knows what change looks like, so the operator carries that change through. And that means when the next time you do a ZTP upgrade, you know that the change is already there in the base config, so it will automatically consume it. So it's a kind of two-pronged approach. which suits our architectural methodology and our operational experience. So let's hopefully, am I near? I'm near. I'll try and get a demo running. CC4? Yeah, cool. So that OCI artifact that I was suggesting in CD, I've replaced that with a bucket for ease. So like think of an S3 bucket, a blob store, just for this exercise, but that would be an artifact, and that artifact would represent a site, and that site could contain infinite amount of switches or configurations for those switches. So here we should have a customization, which in Kubernetes terms is just an overlay or a templating extension method for making an application out of that base source. And in this source, we have our Sonic switch, which you can see just by the name on the left-hand side, and the custom resources of inventory, platform config, switch port config. So in an inventory instance, that might be very small to see, but hopefully you get the idea. We're pushing out the asset details of a MAC address, an IP address, SSH, HTTP reachability, that kind of thing, and its image as well. And if that image changes, the controller that runs on this will actually SSH in and runs a DP upgrade, so that we can also control the image of Sonic declaratively without having to manually, play around with multiple switches or run Ansible books and not understand what the state of our overall site or wider environment is. And that's exactly the same for our platform config, which will carry everything from TACACS, NTP, DNS in future shortly, BGP peerings, subnets, prefix lists, route maps are all getting pushed into the platform, and our switch port config, which is here, which carries our VLAN VNI details. It automatically disables and enables IPv6 depending on whether or not the peer was previously part of a BGP unnumbered group. So we have baseline configurations that are augmented by this kind of custom resource. And hopefully, just while I'm doing this, I can flip over and change. So I'm just going to change. Currently, it's on Ethernet 4 that we've got this VLAN configured. This is going to update a bucket over here. That bucket this is like a pipeline running in 3 seconds. And this is the fun thing to play around with today. So Cameron, I appreciate problems in demos wherever you are. And hopefully, while I'm talking here, I'm a little bit over time. This will actually try and reconcile on the fly and change that Ethernet interface from Ethernet 4 to Ethernet 40. And hopefully, we should still see, there it is already. So the change has already been enacted inside the custom resource to Ethernet 40. And this is now going to take a run through. In our environment, this runs through incredibly quick. On bare metal, with a bare metal Kubernetes cluster or a virtualized Kubernetes cluster as the control plane, this will run 3.5 minutes. But as you can see, it's just started reconciling at the bottom there. And it's because this is all running in my laptop, it's going to take about 2 minutes. So that is not reflective of how fast the system is. While that's happening, I'm happy to field any questions. I know that's a lot of information. Yeah.
Is there any way for anyone in this room outside of the Deutsche Telekom guys to have our hands on it, to either as, for our own infrastructure to play with it, or as you said, it's mostly open in principle. I know there are parts that are probably part of Weaveworks, but I wonder if it's available for regular consumption.
Sure. So on the first instance, Weaveworks are an open source company. Everything I'm showing you is open source. I'm using Flux and I'm using Gitops, and this is Gitops OSS. So it's sitting right on top, can run in a single cluster. You could run a full site and more if you wanted to run all sites behind one control plane. That's completely fine. It was built on Operator SDK, and we would love to upstream and open source the Sonic operator that we've written. The one interesting thing I think that folks will find is that what's great about Operator SDK is building your own controller. So we would release, with a view. I think we've talked about product roadmap and saying let's put this out there. But I would say to everyone that we're doing a specific thing for BGP, VPN, and maybe someone else wants to do just layer 2 things or just layer 3. And what I found that was great was there's tools that all of us in networking are already familiar with. We're already familiar with Bash and Python and Ansible, and Operator SDK unlocks that for you. So we had to do a little bit of adjustment to make it do everything that we want, but in conjunction with Flux, that is totally accessible today, and that's the real, for me, this controller could also be a cross-plane Ansible provider. It could be it could be a completely custom-written Go controller. Like it could be whichever path you choose to, but for us, Operator SDK was great, and we'd love to put an example out there in the future.
So you don't have like a getting started page where people go and have a look at what you did and work from there?
Not right now, but literally, I would happily talk to you at any point today to just give you a 20-step plan, and that's just the same as Jens. Like my email will be free, and I'll be floating around today and tomorrow, and yeah, I love talking about it. It's a really interesting subject. Cool question. Thank you.
Thank you so much for the great talk. Actually, it's pretty impressive, like how all of those tools work with each other. So I've been working myself quite a while with configuration as code and those things, and usually at a certain point I end up with quite a lot of configuration as code, and then usually it gets to the point where the only person that can actually understand the configuration is the person that is maintaining the code or has written the code or is actively involved in that part. So meaning that there is the gap of, there is no documentation anymore actually, which was probably used in the older days to actually generate the configuration. But now that you automatically do all of those steps, nobody bothers to do this documentation part anymore. So usually at a certain point people keep asking, can I have documentation generated at the same time, or can I have documentation as an input? Mm-hmm. Is there any part here where you link that either as input or auto-generate output there as human-readable documentation in the sense of not code?
So I think that, so in the first instance, although we focus on the delivery side of things, the configuration as code part for us is a pipeline that is built. So we actually took the Sonic, we took the Yang definition from upstream Sonic. We built the JSON schema out of that, and then we extended that with validation using Open Policy Agent. So we actually have, like a lot, when I say we validate in lint, I don't just mean to the standard that makes a config sane. I mean that a lot of our actual, like we know what VRFs we need in there, we know what VRFs from a given list would need to be there. So we actually try and codify that logic, because a lot of the times people are asking in the first instance for documentation because the logic is insufficient, so that when things go wrong, they're like, why did it go wrong? So we try and put all of those flags in place, and that's literally, you can try and build a router config on your laptop. It's a Docker toolchain that works really well. It was heavily based on Vincent Burnat's work in Jerrycan, and we did a very extended fork of it that doesn't resemble it anymore. And in the other instance, it's a templating engine. There's no reason we couldn't just write another template and make a docs folder and put all of our docs in there. I think that there's definitely areas where we would love to put more documentation down, especially for whenever we're handing this over for other people to run. And you can never give everyone enough information, but this system's extensible enough for sure to be able to do that.
So everything you've shown here is the source of truth or the config files or the pipelines you're triggering is all of that instantiated manually, i.e. there is no automation triggering source of truth changes, being the config files, right?
The config files are all generated using a template-based system, And
But that's manual, right? As in
Sorry?
the templating is manual. There's no automation which is changing that dynamically, like in a feedback loop kind of situation.
so
Like something happens on the network which changes the config file, which triggers the pipeline.
I see what you mean. Is it bidirectional? No, it's not. Like, we're not able to consume state. Like, as in, like, to take a complementary view, like GNMI, where in GNMI you would see the state change, and the state change would be streamed to you. No, this is very much a declarative system. What we say over here needs to happen here, and if something happens here, our reconciler, so Flux, will run, and that actual inventory, that whole process will run on a 15-minute loop. So anything that's changed in the network will get changed back.
So to follow up then, one of the, let's say, challenges we have seen with this type of approach, where there is an external automation system that overrides whatever change happen in the network. As you said, now you do it every 15 minutes or so, is that if there is an incident and somebody has to jump in and fixes things on the fly by changing maybe the device configuration itself, then the automation goes back and overrides the fix, and then the problems come back. And you maybe didn't have time in those 15 minutes to go back and change your Git manifest and so on and so forth. How do you address that problem?
So I'm just going to push the suspend button. So I'll just suspend this reconciliation, and this will not reconcile any more data there. And if I need to, what I can do is also disable. So the way that we've written the operator, we can enable and disable various levels. So we can enable and disable any custom resource from the inventory parent, and we can also enable and disable like feature flag, different features. So in the first instance, I would make sure that Flux isn't going to, consume a change that another engineer pushes while we're trying to manually troubleshoot and revert something. And in the second instance, I would disable something that I thought, look, people still need to push changes whilst, this needs to run for a week like this, say. Then I will disable, I'll feature flag out that specific configuration area. Ideally, it'll be in an area that works with a feature flag that we've already written. But we've tried that's the magical challenge of Gitops for infrastructure for sure, is if you want to build a declarative system, you have to basically reverse engineer what it would look like as software for operators as we use it today, for sure. Good question, thanks.
Hello.
Hi.
I wanted to ask, in this discrepancy that may happen in the background, just that Andrea was mentioning, is there some report about the diff that happened in the background that was not done by the automation tool? So if it's done manually or something that you didn't intend it by the automation tool, is there a report? If it's going every 15 minutes, you get a report about the diff. So you suspend it automatically, and then you don't proceed with any change. Because I have a feeling that there is a missing link here.
That part where you
about the control.
Yeah, the don't proceed with any change part would be a custom extension. The notification, so I don't have any notifications set up because this is literally a sandbox instance, but you could notify on drift for certain types. As of the latest version of Flux, we notify, I believe we can do remediation and detection on Helm. So, again, this is like how new this world is in that sense, that we're literally working on things that were never thought about as being Kubernetes, when it's a switch that is attached to a control plane. But the idea that you have is something that we get questioned about a lot, and we build custom integrations for folks depending on those needs. So
Thank you.
Cool. Yeah, I'm really over time. Good. Yeah.